device. So it can either write into these registers, and each one is assigned an I/O port, or it can do a map control register into a space in memory, which is called memory mapped input-output. So how does the CPU communicate with device registers? It can either have each control register is assigned an I/O port, which is a number between 8 to 16 bits, the set of all these I/O ports form the I/O port space, which is protected by the operating system. Only the operating system can access it. So either we assign these I/O ports to each register, or we can map all control registers into a memory space called memory mapped I/O. For example, the Pentium uses the memory mapped I/O. The first approach, we have ports, I/O ports for each register, and the second approach is we map these into memory space. So there's a particular space in the memory. With Pentium is from 640K to 1 megabyte. Addresses are used for data buffers. Or we could have a hybrid where we have both of these. go through the bus. So let's say we're using the memory mapped approach, memory mapped IO. So we have mapped these IO controller registers into the memory. Instead of going through the bus, which could be slower because there's a lot of things going through the bus, we could have this dedicated high-speed bus that goes directly from the CPU to the memory. So the CPU would read and write over this high bandwidth bus, which would speed up the processing. So the memory port is to allow I/O devices to access to the memory directly. So this is called direct memory access, or DMA. So the CPU needs to address the device controllers. It can request data from the I/O controller 1 byte at a time, but if it does that, it's going to be very slow. So requesting data from I/O controller 1 byte at a time would waste CPU time. So this DMA controller, direct memory access controller, is a hardware device which we can make available on the motherboard or parent board. And this device will regulate transfers to multiple I/O devices simultaneously. So this direct memory access controller is on the motherboard, and it handles addressing of I/O devices. So it can handle many devices at the same time, and it's independent of the CPU. And it contains several registers that the CPU can read. In other words, instead of keeping busy the CPU of reading and writing into I/O devices one at a time, we have a separate hardware controller that handles the accessing of input-output devices, oftentimes many of them simultaneously. This is to save or shield the CPU from doing all these operations. So we're saving CPU time in this way. So the CPU is doing some processing. We have to access an I/O device. So we would access direct memory access controller. He will give you the address and the control or commands that it needs to issue. It would transfer the request to memory and access the external device. And the external device might transfer any data in and out of memory. It will have a buffer where we could store the commands or any state information for that particular device. When the device is finished with the operation, it will issue an acknowledgement to this